So today we're starting here with inversions of intervals. We talked about analyzing the intervals, perfect, augmented, major, minor, diminished. And we had our two categories of intervals. We had our intervals that could be perfect, augmented, or diminished. And those were our octave, fifth, fourth in unison. Those are that category. Then we had our other category of intervals, which were sevenths, sixths, thirds, and seconds. And these intervals could be augmented, major, minor, or diminished. So you'll notice that perfect is replaced by being either major or minor. The augmented and diminished apply to all categories of intervals. But that's our difference there. Major and minor replace perfect, or vice versa. So you will never have a perfect sixth or a perfect third. That does not exist. Nor will you ever have a major fifth, major fourth, or major octave. Now when you invert an interval, so let's just take an interval. Let's say we have a perfect fifth. And let's say that interval is C to G. We always go from bottom to top, right? C, D, E, F, G. So that's where we get the fifth. The G is in the C major scale, therefore it is perfect. Inversion means that we're flip-flopping the bottom with the top. So instead of C up to G, we're going to now go G up to C. It's the same pitches, but we're making the top note the bottom note. So when we do that, G, A, B, C, it becomes a fourth. And then we ask our question, is C in the G major scale? The answer is yes, therefore it is perfect. This is therefore the inversion. A perfect fourth is the inversion of a perfect fifth. And every interval has its inversion. You can invert any interval. Again, inversion means that what was the bottom note is now on top, and what was the top note is now the bottom note. And we're always determining intervals from bottom to top. So that makes a huge difference in what we name it. Let's do another one. Let's take a perfect fourth. Say we start with this, perfect fourth, G to C, and we flip-flop them. Obviously, you go back to the perfect fifth. What we'll find is that every perfect interval, when inverted, let's call this inverted, stays perfect. So perfect intervals, even when inverted, will always stay perfect. Let's take an augmented interval. So let's switch that around, and let's say we have E to B sharp. That is a fifth, because E, F, G, A, B. Is B sharp in the E major scale? The answer is no. It's a half step larger than what we would expect. Therefore, it is augmented. So E to B sharp, augmented fifth. Now if we invert it, right? Now we're going B sharp to E, B, C, D, E. Notice I didn't say B sharp because when I'm figuring out the number, I just count the letters. B, C, D, E, so it's a fourth. Then is E in the B sharp major scale? Well, first, I don't think about B sharp major scales too often, so I'm going to ignore the B sharp for a moment. And I'm just going to say, well, is E in the B major scale? The answer is yes. Therefore, B to E is a perfect fourth. But when I apply that sharp back in, I say, well, B sharp makes this interval a half step smaller. So instead of being a perfect fourth, it becomes a diminished fourth. You will find that all augmented intervals become diminished intervals when you invert them. Okay, whenever you invert an augmented interval, it becomes diminished. And let's take a diminished interval. Let's go here to, actually not that. We'll start with, so here, A to D flat, A, B, C, D, it's a fourth. Is D flat in the A major scale? It is not. We expect a D in the A major scale, so A to D is a perfect fourth. This is a half step smaller, therefore it is a diminished fourth. If we then invert and say D flat on the bottom, A on the top, you'll find D, E, F, G, A, that the numbers, when you add them together, always equal 9. So there's a couple things that you're gonna find out. Perfect stays perfect, augmented goes to diminished, diminished becomes augmented. And in all cases, the sum of the two numbers equals 9. This aspect of the sum will apply for sevenths, sixths, thirds, and seconds. However, since we don't have perfect to stay perfect, what's going to happen with major and minor? We'll find that augmented sevens become diminished seconds, because 7 plus 2 is 9, and they flip-flop. And but here, let's test out and see what happens. So we know C to E. C, D, E, it's a third. Is E in the C major scale? Yes, it's a major third. We invert this. It is now E on the bottom and C. I'm not even going to count. I'm going to use the power of math. Right? So the sum has to be 9. We have a third right here. 9 minus 3 is 6. Power of math. So we know our inversion will be a 6. Let's just check it to be sure. E, F, G, A, B, C. Yes, math works. Now, is C in the E major scale? No. We actually have C sharp, E to C sharp in the E major. This is a half step lower. So it's not in the major scale, half step lower means it's minor. So you will find that major becomes minor when you invert. When you invert a major interval, it becomes a minor interval. And guess what? Surprise, surprise. A minor interval will become a major interval when you invert it. So this is kind of our formula right here, what we're going to remember. The numbers will add up to 9. Perfect stays perfect. Augmented becomes diminished. Diminished becomes augmented. Major becomes minor. Minor becomes major. Now you can always figure it out by hand, but this is a quick way of also identifying those intervals. So if I just say diminished fifth, without even thinking hard, I can just go augmented fourth, because 5 plus 4 equals 9, and diminished becomes augmented. And you can check it, but it'll always turn out that way. Now, moving on to our next area of interest. Determining consonant versus dissonant harmonic intervals. Harmonic intervals means when you have those intervals being heard at the same time, versus melodic intervals, a scale, a melody. So, the word consonant and dissonant actually needs a bit of clarification. There is a cultural aspect to the perception of consonance and dissonance. So there's certain cultures, certain times in history where music is a little bit more dissonant or a little bit more consonant than other times. There's also a fundamentally acoustic human perception understanding of consonant and dissonant as well. That's universal, regardless of time or culture. And that's going to be the one that's the most important to us. And it's based on the overtone series. Now this might blow your mind if you haven't heard this before, but when you hear a pitch, let's say you're going to hear a C. What makes that C sound like whatever instrument that's creating that sound is notes that are vibrating sympathetically above it, overtones. And there's a specific set of overtones. And depending on how strong those overtones are is why a bass, a bowed bass, sounds different than a tuba, sounds different than a piano. They're all playing the same pitch, but their overtone series has different, like an EQ on a stereo, has different intensities. So the first overtone, so this would be called your fundamental. And this is what you hear as the pitch. Your first overtone is an octave above that. Your next overtone is a perfect fifth compared to the note it preceded. The next one above that is yet another C, another version of the pitch of the fundamental, 2 octaves high. The next would be an E in this case, or a major third, and then finally another G. So if we look at this, C, C, G, C, let me write that correctly, C, E, G. This is the nature of sound. This is acoustics. Doesn't matter what country you're from. This is how sound works. It's no surprise that the octave is considered a consonance, right? So we have, under consonant intervals, the perfect octave is definitely going to be a consonance. It's lower on the overtone series. People often say, oh, it sounds good together. Yeah, but that doesn't take into the cultural side of things, and good is a very subjective, qualitative term. What's more relevant is this. C to G, that's a perfect fifth. That's also very, very consonant. Then we have C, E, G, and this is just a little preview that doesn't necessarily deal with this. It is not an accident that the major triad is the foundation of harmony. It's because it's the first thing that occurs naturally in the nature of sound and how human beings perceive sound. So this is not just cultural, this is science. This is the nature of reality. So when we're looking at dissonant intervals, things like sevenths and seconds, those are always dissonant. In terms of quality, augmented and diminished intervals will always be perceived as dissonant. I'm going to write it over a little bit here. I'm going to make a box here. Perfect, major, and minor. Octaves, fifths, unison, thirds, sixths. These are your consonant intervals. Sevenths, seconds, and anything that's augmented or diminished are your dissonant intervals. There's one number I've left out. It's the fourth. The fourth is a tricky interval. It depends on its context, whether the fourth is perceived as consonant or dissonant. In the overtone series, C to C is an octave, C to G is a fifth, G to C is a fourth. One would expect that a fourth sounds pretty consonant because it's occurring so low on the overtone series. There's more notes that go above this. That's when things get complicated, and that's where we get our dissonances. But C to G, you would think is a consonant interval. And in this context, where you hear a lower note as a foundation, it is. But if the fourth occurs directly over that bass note, so instead of a G occurring between the G and the C, where really there's this C down here that we kind of hear as our fundamental bass, instead, if it was C going to an F, it's going to sound like a dissonance. So if it's a fourth with the bass, it's dissonant. And the reason is when we get forward in music theory, it'll sound like a suspension. And we haven't talked about that yet, but if I play something for you like that, and I say, there's your fourth, and the resolution is to the third. So that's with the bass. A 4-3 suspension, and again, I'm getting ahead of myself, I know that. That 4 against the bass wants to go down to the third. So it would be as if instead of having this G here, I had an F. And what that F really wants to do is go down to the E, which is part of the overtone series. That's essentially what a 4-3 suspension is. Replacing that E overtone with an F. And that will create a dissonance. Dissonance really is a certain kind of tension that human beings perceive with the nature of sound. So dissonance is tension, consonance is relaxation. I prefer those terms far more than sounds good together, sounds bad together, which some textbooks will use. It's too simplistic and it's misleading. Because dissonance can sound good when used appropriately. And consonance can be boring when used inappropriately. So it's not so simple as good, bad. What it is tension, relaxation. And a good composer knows how to go back and forth between those two states to create an amazing piece of music. And that's kind of what we are learning when we're studying music theory. We're learning what's the nature of sound, the nature of reality, how do these intervals relate to each other, such that we can manipulate consonance and dissonance so that we can make people feel something. And that's the power of music. All right.